Good morning, everybody, and welcome to week 9 of our 15-week CWS webinar preparation course for the Water Quality Association's CWS certification. I am just fumbling all around what the name of this course is. It's a preparation course for that some kind of water treatment fundamentals training thing. Anyway, that's what it is, week 9 of 15 weeks. Welcome, everybody. It's going to be a fun one today, I can tell already. I wanted to say thank you to everybody for being here. I really do appreciate the opportunity to serve you in this way. And as always, it's my goal to make sure that the information that I give to you is at least as valuable as the time you're giving to me. I really do appreciate it. Thank you. Make sure I get everybody muted here. I can get the background noise. What we're going to talk about today is some pH review. Now, we did talk about this when we did chemistry, but we're going to talk about some pH review. So the scale, the pH scale, the high and the low. We're going to talk about pH modification, corrosion, corrosion treatments. And so let's go right into the review. Acids, bases, and salts. So basically, no, that's not what I meant. So when various cations, that's positively charged ions, and anions, negatively charged ions, are found in solution, when they combine, the resulting compounds are classified as acids, bases, and salts. Acids are compounds that release hydrogen ions in a solution. All right? So if you take a compound and you put it in water, for example, if it's got a lot of excess hydrogens on it, then those hydrogens are looking for something else to stick to, and that's an acid. So if a solution has a lot of excess, if the stuff in the solution has a lot of excess hydrogens to give away, that's going to be an acid. Acids have a characteristic sour taste, so think of lemon juice. They have the ability to change the color of litmus paper from blue to red. They react with bases to form salt and water. And they really like Pink Floyd music because that's what acids do. Bases are, that question may not be on the exam. You may not see, that's just general information. Who is an acid's favorite music band? Pink Floyd. Although they do like a little Jim Morrison and the Doors too. That's really a lot of 70s music. Steppenwolf. They're kind of really into that. Acids are. Bases are compounds that release hydroxide ions in solution, and they accept hydrogen ions. Hydroxide, you may recall. Get my little pen here because I'm going to draw because everybody loves Kelly's artwork. Remember Mickey? Not bad at doing a touchpad, is it? Mickey normally has 2 ears, right? So the 1 oxygen and 2 hydrogens. Well, a hydroxide ion is chart crazy. Hydroxide ion is Mickey with only 1 ear, right? So that's a hydroxide ion. So a hydroxide ion or a base is a compound that releases. Basically, what they do is they've got a lot of excess oxygen in there, or it doesn't even necessarily have to be excess oxygen. It could be anything that wants a hydrogen ion. So a lot of times it's going to be hydroxide because remember, hydroxide ion is Mickey with 1 ear and it's looking for that other ear. It wants that other ear. So basically a base is anything that wants those hydrogens, that's looking for those hydrogens. That's a base. They tend to have a bitter taste. They give a soapy feeling when applied to the skin. They have the ability to restore the original blue base blue. I think gin, it was good. They have the ability to restore the original. The timing on that was almost as if you'd heard this before, like we were in sync. The ability to restore the original blue color of litmus paper that has been turned red by acids. And the ability to react with acids to form salts. Salts are when strong acids and strong bases get married, they form water and a neutral compound called salt. So it doesn't have to be just sodium chloride, though. It could be calcium chloride. A lot of different things are salts. So a salt is usually a metallic anion and a non-metallic, a metallic cation and a non-metallic anion. So when anions and cations get married, they form salts. So they're generally made up of metallic cations and non-metallic anions. And then remember this chart, we talked about this, just basically a different, the monoprotic and polyprotic and amphilites and non-amphilites, blah, 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 blah. Okay, in no way are you ever going to need to know any of that stuff. Alkalinity. Alkalinity is caused by the presence of bicarbonates and carbonates and hydroxides in the water. It has a drying effect on the skin, and it gives the water a soda taste. The pH scale, if you recall, and we talked, this is review, we did talk about this once before. pH, see here's the thing, when you run a Google search on pH, pretty much, what does pH mean? Almost all of them out there are going to say potential of hydrogen. But if you happen to know somebody who knows chemistry, and you run across them and you say, well, pH means potential of hydrogen, they will give you this big, long lecture of how pH doesn't actually mean potential of hydrogen. And by the way, the book even says pH means potential of hydrogen. It's technically incorrect, although it's sort of like, how when you're in Atlanta, Georgia, and somebody says, hey, you want a Coke? And you go, sure, what kind do you have? And they go, well, I have Pepsi, I have root beer, I have orange, I have, and because everything is a Coke, right? They've branded it. That's kind of the way pH and potential of hydrogen is. Okay? So Jen's right. If you see this somewhere else, use the book. But just be aware that it doesn't actually mean potential of hydrogen. It's sort of like, like I said, Atlanta, and the Coke thing, right? So pH, always a lowercase p and the capital H. Okay, the P is a mathematical shorthand for the negative log base 10 of a number. H does stand for hydrogen. It's always capitalized, and it's the concentration of hydrogen ions in moles per liter. This is a pH scale. I like this scale because it shows some of the stuff that, the normal ranges of different things that you find: ammonia, lye, baking soda, seawater, so on and so forth. Kind of cool. So basically, pH is just a field measurement to determine whether or not the water is going to be corrosive or have a bitter taste, or has the possibility to form scale. pH goes from 0 to 14, 7 being neutral. pH of 7 means you have an equal concentration of free hydrogen ions, the substances that want to bind them, and substances that want to bind hydrogen ions are called bases. The pH scale is a tool for judging what to do with the water in the field. It's a field test. pH is below 7, we know we have excess free hydrogen and we need to add something that wants them, like carbonate from calcium carbonate or lime. If you have a pH above 7, you have more alkaline substances than free hydrogen ions and you need to add something like citric acid to bring the pH down. Here's the scale. I really like this one. Just because, look at this. 1, pH of 1, all the way down here, this guy, your stomach acid, the stomach acid is hydrochloric acid secreted from the stomach lining, has a pH of 1. That's like, wow. And especially when you consider that this is a logarithmic scale. So what that means is that a pH of 6 is 10 times more acidic than a pH of 7. A pH of 5 is 100 times. pH of 4 is 1,000 times. 10 is 10,000. So at that 1, you are 1 million times more acidic than a pH of 7. Your stomach acid, your stomach lining, 1 million times more acidic. That's incredible to me. I mean, look at battery acid is like 10 million times more acidic. And it doesn't matter where it's at. Okay, so a 12 is going to be 100 times more basic than a 10. A pH of 12 is going to be 100 times more basic than a pH of 10, right? So it doesn't make, you just add however many spaces there are, you add that many zeros. And you may see that again somewhere. There are low pH regions in the U.S. Along the eastern seaboard, New England, Oregon, Georgia, Washington, Tennessee, the Carolinas. Low pH waters are generally low in total dissolved solids and in hardness. Not always the case, but generally speaking, it is that way. Rainwater is usually 6 on the scale, but it can be a lot lower due to pollution because remember, carbon dioxide in the atmosphere it forms with water to form carbonic acid. And so the more carbon dioxide you have in the atmosphere, then the more acid rain it's going to be, the more acidic the rainwater is going to be. If you have an area where you don't have as much calcium bicarbonate in the ground to grab those hydrogens, those excess hydrogens in the water, then the water is going to stay acidic. And so you basically, that's why you treat it with calcium, with calcite, right? Is you're essentially in a calcite filter, a neutralizing filter, you are doing in that tank what nature does naturally in most parts of the country. So you are creating, you're creating hardness in the water. So the water is running through that, and the calcium, the calcite is attracting those excess hydrogen ions and bringing that water up to neutral. Rainwater is typically about 6, but it can be much lower due to pollution. Carbon dioxide will only take the pH of the water down to about 4.5. If it's lower than that, then you usually have something like a strong mineral acid like sulfuric acid, which is caused from the oxidation of iron pyrite in the water. Low pH waters, carbon dioxide usually it easily escapes the water because it's a gas. So you got to test it pretty quick after you take the sample to get an accurate reading. High pH waters can also be corrosive and damaging to the metals. It's less common to have pH values greater than 8 in private wells. If you do, then it's an indication that something's leaching into the well, like caustic soda or nitrates that show up as ammonia. It does cause a soda-like taste and dry skin, and it turns litmus papers blue. Litmus paper, blue, remember? Like Sesame Street. Corrosion. I do have a lot of corrosion pictures, a lot more corrosion pictures on the website, so you can take a look at that too. Corrosion is caused by a few different things. Corrosion is the tendency of a metal to revert to its natural state as an ore. Different metals corrode in different types of water. There are factors that affect corrosion. There's the water chemistry and the source of the water. The plumbing type will affect the corrosion, the amount of corrosion. Temperature will affect corrosion. Warmer water is going to corrode faster. Flow velocity, although Tanya Lubner, Dr. Lubner, PhD in chemistry, one of the smartest people I know, Director of Education for the Water Quality Association, pointed out that flow velocity is actually erosion. The book says flow velocity. It lists that as one of the factors affecting corrosion. But Tanya pointed out that if you have pitting or corrosion of piping due to flow, it's more erosion than it is corrosion. Electrochemical reaction, though, this is one that a lot of people don't think about, but absolutely will cause it. I have seen a lot, actually, houses that have major problems with their copper plumbing or with their metal plumbing because of electrochemical reaction. Oxygen in the water, dissolved oxygen in the water will absolutely cause corrosion. I have a customer here in Michigan that has a ton of dissolved oxygen in the water, and you should have seen the havoc it wreaked on their plumbing system. Incredible. I mean, it just destroyed their copper plumbing. Acids will also cause it, and galvanic action. So this is a picture of iron corrosion. The corrosion of iron can take place in the air as well as in water as long as moisture is available. You'll notice on this fence post, the amount of corrosion is heaviest right down here near the ground. The metal fence posts provide an example of both oxygen and moisture and corrosion. Above the ground, the post is exposed primarily to oxygen. Below the ground, they're exposed primarily to moisture. But most of the corrosion takes place right at ground level where both oxygen and moisture are present. So you definitely need oxygen and moisture or when you have those two things combined, rather, that's when you get the bulk of the corrosion. So you have a nobility scale when it comes to metals. And on the most noble metal that we have is gold. Now what that means is that it's the least likely to corrode. It corrodes it's the least likely to revert back to, or to be successful in reverting back to its form as an ore. Okay. Potassium is going to be the most reactive, the easiest to corrode. Potassium is. Gold is the least. Now, a lot of people would think that iron is the most corrosive because that's where we always see that, rusting cars and rusting metal and stuff like that, but it's actually not. You actually have 6 more metals more corrosive than iron, so more reactive than iron are. 6 metals more reactive than iron. And by the way, remember when we talked about the smell in the water heater and what caused the anode rod? We said that most water heaters put a magnesium rod in that water heater, and that dissolves at a certain speed, and it dissolves at that level, at that speed, because it has calcium in there. The calcium kind of blocks some of the corrosion. It actually kind of has a coating a little bit, and if you have a water softener, you don't have that calcium building up on that rod, so that rod dissolves a lot faster. It corrodes or dissolves a lot faster. So the solution is to put in an aluminum zinc rod, so a rod made out of aluminum zinc, which you'll notice does not dissolve as fast. It's not as reactive as magnesium. Okay? So that's why you would replace that with an aluminum zinc rod. Some metals are more chemically active than others, but some, like aluminum or zinc, form a protective coating as they corrode. So the corrosion itself protects itself from further corrosion. So that's kind of important. You may see that again. Some metals, when they corrode, actually protect themselves from additional corrosion. They'll put a coating on themselves, and that coating continues to protect itself. The reason iron, we think of it as rusting or corroding faster than other metals, is not because it does, but because it flakes off, and that constantly exposes new surface to corrode further. So there are some byproducts you can use. So byproducts like hydrogen gas or zinc carbonate will act as a protective layer against corrosion, but if water is flowing and it washes it away, it's not going to protect the metal. Water is actually a pretty decent insulator. Now, we talked about this early on, and we will mention this again when we talk about drinking water systems, but water is actually a pretty decent insulator. So water by itself does not conduct electricity. In fact, when you look at your TDS meter, your total dissolved solids meter, it has these 2 little prongs in it. And what it does is it shoots a current from one to the other, and it measures the speed that current travels. The faster the current travels, the more stuff is in the water. Because it's not the water itself that carries the electrical current. It actually is the stuff, water is a universal solvent, so it tries to dissolve pretty much everything it touches. It's the stuff that's in the water that carries the electrical current. We can measure how much stuff, or get an indication of how much stuff is in the water by measuring the conductivity of the water, how much current the water will carry. So water, like I said, is a pretty decent insulator. It's the stuff in the water that carries the current. That's the total dissolved solids, or the TDS. And incidentally, organics don't carry a charge. So if you take a cup of pure water, absolutely nothing in it, You put sugar in there, and you check the TDS, it's going to read low or very low. It's not going to read anything. Sugar, it's going to dissolve in that water, but that's organic. You add salt to it, the salt is going to form sodium and chloride ions, and that does carry electrical charge. And so a total dissolved solids meter does not tell you what's in the water. It does give you an indication of how many dissolved solids are in the water. When you submerge two dissimilar metals like zinc and copper in a fluid that carries electrical current, they will send an electrical current between the two metals. So that's why if you have two dissimilar metals, let's say you have galvanized copper, galvanized pipe, and copper in a house, then you will get the weaker metal. The softer of the metals is going to corrode, and you will get that, especially as the water is flowing through. And if you have you have heavy TDS, total dissolved solids in the water, you'll get corrosion, especially at the joint of that copper plumbing. One of the metals will gradually dissolve. The higher the total dissolved solids, the more the corrosion, because more electrical current is traveling through that water. Free oxygen and corrosion, that oxidizes the metal the same way moist air rusts unprotected metallic surfaces, right? You have oxygen and you have moisture, so it's going to corrode the same way unprotected metals would. Typically forms pitting rather than a general attack on the entire surface. So what not to do for corrosion? So you have people, we've talked a little bit about coating, we talked about the anode rod. So a lot of people say, well, why not just leave the hardness in the water, and that will form scale buildup on the inside of the copper plumbing and it will protect it from corroding that bad. Well, that doesn't actually work, because when you have joints and turns, and it's not going to be uniform all the way through. So you're still going to have exposed copper as the water flows through it, makes turns. It's not all going to build up uniformly all the way through that copper pipe. What to do about corrosion and low pH or high pH? Well, low pH is you put a neutralizing filter in, and we talked a little bit about that a few minutes ago. You basically are doing with the tank exactly what nature is doing in most areas of the country. You can also add phosphates, and phosphates will bind up the hydrogen and basically put a coating around the water molecule itself that prevents it from corroding. Oxygen scavengers, so if you have really high pH or a lot of dissolved oxygen in the water, then an oxygen scavenger is going to eat some of that. It's going to take that, capture that oxygen. And then coatings and insulating unions, we'll talk about these. Okay, so neutralizing filters. Neutralizing filters contain calcite. So the water pump is pumping it in. It goes through a retention tank first. Then it goes up through here. And you put calcite in here. Now, like I said, this is essentially the earth. It's what nature does in a lot of areas of the country to neutralize the water. So the water comes in and it goes down through this. Now, because it's dissolving, this calcite is dissolving in the water, you have to re-add that. Right? You have to, usually once a year, you go out and you add more calcite to the tank. So you have to service it. And you also need to put over here somewhere, there needs to be some sort of a filter on there, because as these calcite chips dissolve, they're going to create fine little teeny tiny pieces of sediment that are going to come through and get in the water, and so it's going to look like sand, and it's going to clog their screens and that kind of thing. So you have to have a filter over here that will capture those little fines. Now the thing about that is usually you put a water softener in over here, because now you're putting hardness in the water. Even though you had pretty close to soft water here, it was low pH. Here you're bringing the pH up to neutral, but now you've got hardness in the water, and so you have to take that hardness back out of the water with the water softener. The other thing that people will use calcite for, and sometimes they'll just do it in a filter housing like this, they'll just fill a filter housing up. You know those people that complain about the slimy feeling of water? I don't call it slimy when I'm in sales, I call it silky. But you know how some people complain about that. Now, most people I have found get used to that feeling, and in fact, they prefer it. We all know what that feeling is caused from. It's the natural body oils coming to the surface. So when you get that soaky feeling, it's actually better for you. It's better for your skin. You're not clogging your pores with the calcium and stuff like that. But there are those customers out there that just cannot get used to it for any reason. With those customers, you can put a calcite filter in, just a BB filter where they add calcite to it or whatever, and it adds a little bit of hardness to the water so that they don't have that feeling. Each to their own. It is a sacrificial media. That means it dissolves, and you may need a softener after the system. May enhance some of the iron problems, but a neutralizing filter, a calcite filter, also will take out some of the problems as well. So some of the iron, it will act as a kind of a pre-iron filtration, but it may bind up some of that iron. Phosphates react with small quantities of metal ions to form a coating on the walls of the pipes. They can break down with heat and with time, and they're usually injected via chemical feed pump. Oxygen scavengers like sodium sulfite or sodium nitrate can be used if dissolved oxygen is the primary cause of corrosion. They're used primarily for industrial purposes, as you usually can't drink the water after you put those in there. Coatings, galvanized steel with zinc is an example of that. It prevents contact with water in the steel. It heals the breaks in the coating. Glass is one that we commonly see, not necessarily in pipes, but we'll see it in a water heater, for example. They will blow molten glass up inside of a water heater when they manufacture it. Paint is a very common coating. Think of your car. Why do we paint our cars? That's a coating that prevents the metal from rusting. So paint is an excellent coating. The thing is, inside the plumbing, it can be hard to apply or transport, glass or paint or any of the, I mean, think about if you had copper piping with all coated with the inside of glass, and the inside of it was all coated with glass. If somebody dropped that thing or cutting it would be tough. So it's going to be hard to apply or transport. Insulating unions use non-conductive fitting that stops the electrochemical corrosion across the joint. And by the way, just in case you have somebody out there that thinks this, or if you ever see this on an exam somewhere, softened water does not cause corrosion. It does not cause corrosion. It doesn't enhance, it doesn't help corrosion either. It doesn't stop it. It doesn't have anything to do with the pH. Softened water doesn't. All right. Let's just go through some review questions because we have a little shorter lesson today. So let's go through a couple of review questions. We've got enough people on the class here. I'll let you guys type in your answers and see what you think. So this is a multiple choice here. One common oxygen scavenger frequently used in industrial efforts for corrosion is potassium sulfate, sodium sulfate, ferrous hydroxide. Oh, well, I gave you guys the answer. Sodium sulfite is the answer. This chemical is not used for corrosion control in the home because these scavengers blank at high temperatures, are too expensive. So the oxygen scavengers, the chemical is not usually used in corrosion control in the home because the scavengers, what happens with the, why aren't these used in the home? The oxygen scavengers usually. Anybody? Is with me? Answer is C, because it makes the water non-potable. Okay, so the oxygen scavengers generally are not used in the home because they make water non-potable. Oh yeah, I see how you are now. One of you answered privately after I gave the answer. Yeah, that's always safe. No, I'm just kidding. So the gentleman that answered that way, nicely done. Hardness minerals are blank when an ion exchange softener is used. Replaced, neutralized, destroyed. Hardness minerals, good. Good job, Pete. Replaced, that's right. Ion exchange, not ion removal. When dissimilar metals are in contact in a solution carrying an electrical current, certain actions occur. Check any statement below that is correct. An electrical current flows between the two metals. Convection currents are set up in the water. A deep etching of both metals occurs. One of the metals gradually dissolves. Actually, nothing happens if one of the dissimilar metals is copper. What do you guys think? Which ones happen? Which ones are correct? The answer is A and D. An electric current flows between the two metals, and one of the metals gradually dissolves. So not B. Let's look at B. So convection currents are set up in the water. No, it's just A and D. A and D. Nicely done, though, Pete. That was good. Okay, and John, you got A right. Okay, coating steel surfaces with zinc does the following. Check any statement that is correct. The coating prevents contact between the corrosive water and the metal steel. Coating prevents pinhole corrosion from spreading. Coating causes zinc oxide to form. This provides a protective coating when the metal surface is damaged by other mechanical or corrosive action. Oh, the coating can be tailored to any specific corrosion problem. Answers everything except D. A, B, and C. Everything except D. If water is corrosive and iron-bearing, a neutralizing filter may blank the iron. As a result, the iron gel formed in the filter bed could well blank the unit. Any guesses on that? There will not be fill-in-the-blank questions on the exam unless the answers are provided. These questions came directly out of the back of the Water Treatment Fundamentals book. The water is corrosive and iron-bearing. A neutralizing filter may precipitate the iron. As a result, the iron gel formed in the filter bed could well clog the unit. I think oxidize would be yeah, John, that's probably the right. It'd screw up, it'd screw up the unit. Yeah, that would probably, it would work. I think oxidize and foul would also be acceptable answers there, but precipitate and clog are the answers given in the book. Screw up will probably not be one of the choices if you saw that question again, but I like it. Good. In a broad sense, oxidation refers to blank of positive valence or blank and negative valence. You're probably not going to get this question on the exam, so I'll give it to you. In a broad sense, oxidation refers to the increase of positive valence or decrease in negative valence. You're probably not going to get that answer for that question. The most chemically active metal known is, what's the most chemically active metal? Okay. Which one was the most chemically active metal? Do you guys remember? Answer is potassium. And gold is the least. Gold is the least reactive. The use of coatings has become quite popular in combating corrosion. These coatings prevent contact between blank and blank. Any guesses? It's water and metal. Zinc coatings tend to blank where damaged by either mechanical or corrosive action. That's heal themselves. Heal. Heal. True or false? some easier ones here. Neutralizing filters are used primarily to correct corrosive hard water. True or false? Neutralizing filters are used primarily to correct corrosive hard water. True or false? What makes that false, Pete? John, what makes it false? It's correct, it is false, but what makes it false? Well, neutralizing filters are used to correct corrosive water, but what makes this false is corrosive hard water. That's this answer, or this word right here. It's usually soft water. If you have a lot of hardness in the water already, then the neutralizing filter is not going to work as well. So acid water, low pH water generally is low in hardness. Yeah, that's right. Hardness and corrosion are confused in the provided statement. So, but neutralizing filters, this answer would be true if you eliminated the word hard. And neutralizing filters are used primarily to correct corrosive water. If you eliminated the word hard, then or you could also make this true by saying neutralizing filters are used primarily to correct corrosive, naturally soft water. That would also make this statement a true statement, but hard makes it false. Polyphosphates reduce corrosion in all metals except gold and iron. That's false. Okay. That is false. Yep, false. pH indicates the degree of intensity of the acidity or alkalinity of water. Right. Good job, Pete. Pete, if you're, do you mind putting those on, or if you guys are doing that, putting them on publicly so that people, because the chats are recorded and it's helpful sometimes to see the chats and discussion and stuff. Thanks. pH indicates the degree of intensity of the acidity or alkalinity of water. True or false? That's true. Good. Acid waters may cause a deep etching of metals, of all metals except copper and brass. You guys think acid waters may cause a deep etching of all metals except copper and brass. That is false. Okay, acid water is going to cause. First off, metals are not, especially copper and brass, are not. I mean, they're definitely going to be affected by acid water, and then a lot of times the etching is caused from basic water. Well, that's more pitting, but definitely the copper and brass is not going to be exempt from the corrosion. Breaks in galvanized coatings tend to heal themselves. True or false? Breaks in galvanized coatings tend to heal themselves. Yeah. This one is this one is true. And the question is, what's meant by etching? I think it's corroding it, like almost like lines. If you think of like scratches in the pipe, you know, like it's gonna. It's not pinholes. It's different. Etching is going to be different than pinholes. Pinhole corrosion is, you know, where you have these little. I mean, it just corrodes through the weakest areas of the metal. Etching is almost, think of a glass and how a glass looks like, or a glass that's been etched looks like somebody took a Brillo pad to it and it's scratched all up and it's got grooves, like you know, it looks like grooves all the way through, like scratches, deep scratches. That's etching. In this one, breaks in galvanized coatings tend to heal themselves. That is true. Yes, that is true. The only drawback to soda ash is that it requires the use of a sand filter following the feeder to remove any iron present in the water. That's false. Insulating unions cannot be satisfactorily used where joints between metals are too small. That's true. The presence of electrolytes in water enables it to carry electricity. That's true. The presence of electrolytes in water enables it to carry electricity. It's the stuff in the water. Remember, it's the stuff in the water that carries electricity, not the water itself. Billions of dollars are spent annually in the preventing of iron rusting. This is because iron is the most corrosive of all metals. That is false. It's potassium is the most reactive or the most corrosive of all metals. Remember, there are 6 metals more corrosive, more reactive than iron is. On the nobility scale, iron is actually number 7 away from the most reactive. The reason the millions of dollars are spent annually in preventing iron rusting, that's true, but that's because it flakes off and always exposes new surface. That's why it rusts. Hydrogen gas is a byproduct of corrosion and may protect against further corrosion. True or false? Hydrogen gas is a byproduct of corrosion and may protect against further corrosion. That is absolutely true. Definitely true. True. Good save, Pete. That was good. Okay. Distilled water carries about the same amount of electric current as soft water. Distilled water carries about the same amount of electric current as soft water. True or false? That's false. And why is that false? It is false. That's correct. Why is it false? It is false because distilled water does not carry, distilled water is mineral free. It does not have total dissolved solids in it. As opposed to softened water, it does. Softened water, you've taken out the calcium, but you've replaced it with sodium. So you have the equivalent of sodium as you had in calcium, the equivalent weights. So actually, the TDS is usually slightly higher after a water softener because of the equivalent weight. Where corrosion is due to conductivity, an increase in dissolved mineral content increases the rate of corrosion. Where corrosion is due to conductivity, an increase in TDS, or the dissolved mineral content, increases the rate of corrosion. That is true for sure. Exactly. Use of an ion exchange softener does not cause or correct corrosion problems. Use of an ion exchange softener does not cause or correct corrosion problems. That's true. That, everybody, is this week's lesson. Finished a few minutes early. So next week we're going to talk about water potability, disinfection, and water analysis readings. So, and we will be live from the Kansas Water Quality Association next week. So we'll be in Kansas. If anybody's out there, come say hi. I don't remember if any of you guys are from that area or not, but we will be in Kansas because doesn't everybody want to go to Kansas? Wow, that's so much fun. Anyway, I will talk to you guys next week, if not before. Everybody have an excellent, excellent weekend.